When people hear average, they think add numbers and then divide by how many there are. But what if you have a curve instead of numbers? How do you find the average value of a function? Here's the average value formula. The average value of a function on an interval from a to b will be equal to 1 over b minus a times the integral from a to b of the function f of x dx. So you'll want to find the area under the curve and then divide by the width of the interval. That will give you the average value of the function on that interval. For example, if we want to find the average value of f of x equals x squared on the interval from 0 to 2, if we set up our formula, that will be equal to 1 over 2 minus 0 times the integral from 0 to 2 of x squared with respect to x. So if we integrate from 0 to 2 x squared dx, the antiderivative of x squared is x cubed over 3. If we plug in our limits of integration, when x equals 2, that will be equal to 2 cubed over 3, minus when x equals 0, 0 cubed over 3. So that will simply be 8 over 3. Next, we need to divide by the interval length. So the average value will be equal to 1 over 2 times 8 thirds, which will simplify to 4 thirds. In this next example, we want to find the average value of the function f of x equals sine of x on the interval from 0 to pi. Setting up our equation, the average value will be equal to 1 over pi minus 0 times the integral from 0 to pi of sine x dx. Integrating sine x with respect to x, that will be equal to negative cosine x that we'll need to evaluate from 0 to pi. Negative cosine pi is 1 minus a negative cosine 0, that is negative 1. So 1 minus a negative 1 will be equal to 2. So finally, we need to divide by the width of the interval. So the average value of the function sine x on the interval from 0 to pi will be equal to 1 over pi times 2, which is simply 2 over pi. In example 3, we want to find the average value of f of x equals 2x times cosine x squared on the interval from 0 to 1. If we set up our equation, the average value will be equal to 1 over 1 minus 0 times the integral from 0 to 1 of 2x cosine x squared dx. So here we have a product that we can't simplify. We'll use u-substitution. If we let u be equal to x squared, du will therefore be 2x dx, which is what we have in our integrand here. The only thing we need to do is also substitute our limits of integration. So when x equals 0, u will be equal to 0 because 0 squared is 0. And when x equals 1, 1 squared is 1, therefore u will be equal to 1. Now we can rewrite our integral as integral from 0 to 1 cosine u du. And the antiderivative of cosine u is sine u. If we substitute and evaluate, first we plug in our upper limit of integration, sine of 1, minus, plug in the lower limit of integration, sine of 0, and that will be equal to sine 1. So since our interval was from 0 to 1, we don't need to divide by 1. Our final answer will be that the average value of the function f of x equals 2x cosine x squared on the interval from 0 to 1 is equal to sine 1. Here's your challenge for today. Find the average value of f of x equals 3x plus 1 on the interval from 1 to 3. Pause the video and try it before reading the solution. So here's your solution. If you apply the formula, that will be equal to 1 over 3 minus 1, integral from 1 to 3 of 3x plus 1 dx. Integrating 3x plus 1 with respect to x, that will be 3x squared over 2 plus x. Then you need to evaluate from 1 to 3. So when x equals 3, that will be equal to 3 times 3 squared, which is 27 over 2 plus 3, minus, when x equals 1, that will be equal to 3 over 2 plus 1. So that will be 33 halves minus 5 halves, which is equal to 14. And finally, if you divide by the width of the interval, that will be equal to 14 over 2, which will be 7. So if you got 7 as a final answer, you are correct. Remember the formula. The average value is equal to the area under the curve divided by the interval length. Master this formula and you'll unlock a key concept in calculus that connects integration to real-world averaging. Thanks for watching. Please like and subscribe to keep learning with us. And don't forget, math success starts when you stay on the fast track.